Hello my dear children of class 11 science. We will continue today with the same chapter that you were learning in the last class, superposition of wave, number 1, interference and beat. Okay. Now in the last class we had done up to the interference of two wave and the condition for constructive and destructive interference. Okay. So we had done up to that part. Now today's class we do continue with the interference of sound wave and the condition for interference of sound wave. See, as I said, interference can be observed with sound as well as with light wave, because sound can also travel in the form of wave and light can also travel in the form of wave. Okay, and the details of light wave and all you learn in class 12. Okay, but as far as the sound wave is concerned, okay, the sound more than two sound wave can interfere each other. That means they can superpose each other. Now when they superpose each other, then there is some distribution of this sound energy takes place. Okay, and this phenomenon is called interference of sound wave. And sound wave are transverse wave, it can be what? Longitudinal wave. And you know sound wave in air is a what wave? Longitudinal wave. Sound wave in what? Air is a what wave? Longitudinal wave. And when sound produce longitudinal wave, then they also produce what? The state of compression and rarefaction. Yes, children, you have learned in one of the chapter called wave. Okay, the waves like mechanical wave are two types, transverse wave and longitudinal wave. And you know when we talk about the longitudinal wave, what will form? The state of compression and rarefaction is formed in a region. So when two sound wave of same frequency, so try to understand, when two sound wave of same frequency, okay, travel simultaneously in a medium, same frequency travel simultaneously in a medium in the same direction, then at some point both the wave produce compression and some point both the wave produce what? Rarefaction. That is, they meet in each other at the same phase. Means the formation of compression or rarefaction is the point where the two waves will meet each other at the what phase? Same phase. Which means the two waves make the particle of the medium to vibrate in the same direction. Make the particle to vibrate in what direction? Same direction. And at this point, the amplitude is equals to the sum of the amplitude of two waves. And you know the intensity of sound also become maximum. And that's what you have learned, the interference as constructive and destructive interference. Constructive means always the intensity become maximum. Destructive means intensity become minimum. And when constructive interference is formed, okay, when the intensity is maximum, the two waves are always meet each other at the same phase. Means make the two waves make the particle to displace in the same direction. And when destructive interference form, the intensity become minimum, which means the two waves displace the particle in the opposite phase or opposite direction. That means the two waves meet each other at a point in the opposite phase. Okay. So when two wave from different sources, okay, then they propagate in the same direction with the same frequency, they will superpose each other and form this phenomenon called interference. But there will be the region where intensity of sound become minimum and where there will be a region where the intensity of sound become maximum, leading to the formation of destructive interference and constructive interference. Okay, and this phenomenon is basically called as interference sound wave. But for the formation of interference of sound wave, there are certain conditions. That means even if you produce two sound wave, okay, it doesn't mean that the interference of sound wave can be observed. So there are certain conditions for the formation of what? For the formation of interference of sound wave. And there are basically three conditions that you need to keep in mind. One of the first condition that I have highlighted already out here, and that is the phase difference between the wave must remain constant. So one of the first important condition for the interference sound wave is the phase difference in the angle in which the particles vibrate by the two waves must have a constant phase difference. Must what? Constant phase difference. Which means if the phase difference between the two waves at a point varies with time, if the phase difference does not remain constant, then the interference of sound cannot be observed. So under this condition, what happens? The state of interference at any point in the medium will not be sustained. That means cannot form at all. Okay, that's why for the formation of interference sound wave, what is the important point? The phase difference between the two waves or more than one wave must remain constant. So under that case, what happens? There will be a region where the intensity of sound become maximum at one instant, and on the another instant the intensity sound become minimum. Okay, so in this case what happened, you can see the formation of interference of what? Sound wave. That's why this is one of the first condition that you need to keep in mind. Now we have next condition, that is also for the condition of interference sound wave. And number 2 condition is the amplitude of the waves. The amplitude of the waves should be nearly what? Equal. The amplitude of the waves should nearly be what? Equal. That means when the wave propagate in a medium and make the particle to displace, okay, every particle which is displaced by two wave must displace nearly of equal amplitude. It should not be like one wave displace particle with very less amplitude and one wave displace the particle on the same particle by another wave with large amplitude. That means the amplitude of wave should be nearly what? Equals. So if the difference in the amplitude of the wave is large, then is not nearly equals, then at the point where the wave meet in opposite phase, there will be a sufficient intensity of sound. Sufficient intensity of sound. Because the amplitude of this point is equals to the difference in the amplitude of the wave. Hence, the interference will not be clear. The sound will be sufficient, a very, very loud sound. In that case, interference will not be clear. Therefore, for best interference, minimum intensity should be 0. So that the amplitude of both the waves must be exactly equal. Which means the amplitude of the two waves should not be very large, it should be nearly equal. Or if it is 0, if it is equal, then that must be equal, nearly equal. Then intensity of sound wave should be nearly 0. So that is the next condition of interference of sound wave. So what is the second condition you learned? The amplitude of the wave should be nearly equal. Now we have the last condition that you need to keep in mind, that is the displacement produced by the two waves should be along the same straight line. Displacement produced by the two waves should be along the same straight line. If it is not, like if the displacement produced by two waves should not be along the same straight line, then what happens? Then a displacement at a point where the wave meet in opposite phase will not be 0. The displacement will not be what? 0. So under this case, the sustained interference of sound wave cannot be obtained. That's why in the phenomena of interference, total energy of the wave remain constant or conserved. So remember this, interference is such a phenomenon where the energies also remain conserved, because the intensity, whatever intensity of sound, which energy which loss in the minimum destructive interference, that will be reappears in the constructive interference, so that the total energy always remain constant or conserved. So whatever energy, as I said, apparently disappear at minimum intensity or at destructive interference is actually present in the constructive interference. That's why the energy is simply redistributed in the interference of sound wave. Therefore, there is no loss of energy takes place in the interference phenomenon. That's why interference completely based on the principle of superposition